Bismillahirrahmanirrahim. I'm Iqbal Sipra. I'm artificial lift consultant, and I've been working actually for 40 years in the industry, mostly in the major oil companies, Aramco, KOC, and PDO. And right now I'm carrying a consultancy. And I have good wishes for you from all my viewers from Canada. At the moment, actually, I just want to give you my introduction intro, and you can have a look. For a while. This is my intro. I've been working 40 years in the industry. I'm certified professional engineer, ESP specialist in PDO, Aramco, KOC, all together. So just have a look before I switch over to my actual presentation. If you have any question or anything, all you can do is actually you can write it, and it will come to me, and we'll keep the session at the end 5 to 10 minutes for answering the questions. I do have pretty big presentations. Now it is going to take a little while. I understand actually, I will not be able to intervene in between my presentation to answer the questions. So hope you can bear with me. Thank you much. Okay. So let's see what I'm going to talk about. Artificial lift methods. So artificial lift methods, what artificial lift means basically is the means of flow, a well actually which is incapable of flowing by itself to the surface by installing some pump or some alternate devices. So the concept is here. You can see that if flowing bottom hole pressure is less than your static head pressure, the well will not flow. So in this kind of situation, you may need artificial lift means to lift the well to surface. So what's the concept is, there are two ways. One is either the gas in the solution or gas is broken out of the solution. If gas is in the solution, we still have a straight line correlation altogether. But in case, when it breaks out, actually a bubble point, then it deviates and departs from the straight line. So then it's a different correlation applies. So I don't want to go into mathematical details actually at this stage. So artificial lift, when reservoir pressure do not sustain acceptable flow rates on the surface, and no fluid flow at all. So lift process transfer energy downhole or decrease fluid density in the well bore to reduce the hydrostatic pressure on formations. So what are the artificial lift means, and which are commonly used in Oman also? First of all, the oldest method is a beam pump, and then hydraulic pump, and this is also being installed in worldwide and also available in Oman, mostly in water wells. Beam pump is the most commonly used application, means of lifting in all the areas, particularly in Oman also. And the PCP is also being installed, also available in Oman. Gas lift goes to some areas also, and ESP is the most commonly used in Oman. So I don't have exact figures, but the gut feeling is ESP produces 85% production worldwide also, and it's almost same percentage in Oman. Gas lift is and PCP and Duralift are all together 15% for the rest of the application. Numbers are the most numbers are beam pumps, but production wise ESPs are commonly used in for higher rate of production. So I should say that about almost 18 to 2000 ESPs are installed in Oman altogether, and PCPs ranging from 100 to 150. Gas lift is almost about 100 wells, and hydrolift and hydraulic pumps are very little, maybe 50 to 100, not commonly used in most of the areas. The worldwide is 94% wells are on artificial lift, and you can see that this is an old figure. 94 is 2004. You can see that. So rod pumps are 79%, Electric submersible pumps are 12% back in 2004. The figures have been changed now, but I just want to give you a flavor and a picture. So gas lift 3%, hydraulic pumping is 1%, and others 2%. And production-wise and revenue-wise, rod pumps is 717, and ESP is the most, $1725 million. PCP is 369, and hydraulic pump are 30% and 30 millions. Yeah, you can see the most populations around the world. Canada 48,000, North Sea 600, but these figures are not applicable anymore, but just to give flavor. Russia 121, 76,000 in China, Indonesia 9,500, 1,300 in Australia, 2,600 in Oman, maybe more and changing now. Libya and Venezuela, Peru, Brazil, Argentina. So world is 845,000 wells and back in 2004. Now it's much more now increased. So this is application range is, you can see this rod pump is only about 2,000 barrels and it can lift up to 7,000 feet, whereas PCP can go up to 9,000 barrels and lift from 7,000 feet. And hydraulic lift can, in intermediate, in different stages, it can go up to 10,000 barrels, but production is reduced to 2,000. But if you wanted to go to 8,000 feet, 7,000 feet, it's increased to 9,000. ESP covers the most ranges, it goes from 12,000 feet to almost 50,000 barrels. And gas lift is also covers the most, from 12,000 to 5,000 psi. So this is an overall comparison, you can see that. And this is the artificial lift system efficiency, the PCP is the most efficient system. Hydraulic piston is the next, and beam pump is the next. ESP and is in the middle somewhere in 50%. Hydraulic jet pump is the next lower one. Gas lift is also next to last, and gas lift intermediate is the least. Yeah, and these are artificial lift selection methods. I don't want to go on screen in detail, but you can see that there are different ways, and they are installing depths and the ranges. So how to select artificial method application, not on size fits all. One size does not fit all. So I should say that if the scale condition, then gas lift is once acceptable. If there is sand, then gas lift is very good, and hydraulic lift is very good. Paraffin is hydraulic lift is good. ESP is good and good too. Corrosion wise, the best is rod pump, and high GOR the best is gas lift, and ESP is fair and good. Nowadays high GOR ESP is available, and I've installed by myself, and actually in Oman I'm going up to 500 SC per barrel. They can do that. Literally we can pump gas to the surface. Deviation is gas lift is very good, and ESP is good too. But for other wells, you should constrain about vertical, configuration. Depth-wise, the best is hydraulic pump, and then next is gas lift and ESPs. And flexibility-wise, rod pump is more flexible, whereas gas lift and ESP is equally good. And temperature-wise, is rod pump is the most. Yeah, ESP is also good nowadays, and nowadays the hotline ESPs can be installed up till 200, 250 degrees centigrade. They have been installed in the world. I have tried one in different areas of the world. So these are the artificial lift selection criteria in a nutshell. I don't want to go in detail, but this tells you in a graphical picture. Yeah. Now we were coming back to we're coming back to system, one by one. Yeah. So if you wanted to talk about, all the systems one by one, I'm going to take over, takes you to all the systems, one by one. Let's see, what are the pros and cons of different concepts of artificial lifting. Reciprocating replacement and rod pump is transfer of mechanical energy from surface via rod string to downhole pumps. So rod pumps combine a cylinder and a piston together, and they work on a to and fro motion. Advantages are most widely used in artificial method, best understood by field personnel, low intervention cost, remote location can be installed without electricity. It can run on gasoline or diesel, readily accommodates volume changes, and reliable diagnostic tools. Yeah. Hello. Yeah. Okay. Some people are complaining about the sound. But I think there may be some problem with their own system. But on my side, I can see my screen. My sound system is working perfectly. All right. So let me continue with my advantages and disadvantages of rod pump. So disadvantage is actually restricted flow and depth, susceptible to free gas. If the free gas is gas locked, frequent maintenance is required. Deviated wellbore and difficult rod areas not easy to install. And there's a constraint actually. You cannot go more than 21 degrees. From vertical, reduced tubing bore, cannot, because of the rod, the overall effective tubing dies reduced. Susceptible to corrosion, yeah. Potential wellhead leaks are very common because they are rubber components. Now, progressive cavity pump is the next one. It has got two components. One is a rod and one is the progressive cavity pumps are based on rotary fluid displacement. This serial system consists of a rotor and turning inside a stationary stator. This is rotor, and then it's got a tubing string, and the rod string actually which connects to the rotor at the end, and it's run by the surface motor. Yeah. PC pump applications is heavy and viscous oils, production of solids, latent fluids, medium to sweet crude, coal and methane gas, urban areas and agricultural areas. So progressive cavity pumps advantages, disadvantages, I've already explained it. So what's happening? I think there's some mix up. Let me take you from PC pumps onwards. Yeah. So okay, progressive cavity pump is just coming back to the same screen. It are two components. One is a rod and one is a rotor, and installed in rotor installed at the end, and it's run from the surface by a motor. Yeah, and you can see the comparison actually the size between compared to the rod pumps and the beam pump. So what are the applications? In the heavy and viscous oils, production of solid latent fluids, medium to sweet crude, coal and methane gas, urban areas, and agricultural areas can be installed. So progressive cavity pump advantages is simple two-pieces design, excellent for viscous crude, resistant to abrasive and solids, non-pulsating, does not gas lock or emulsify fluid, oil cavities from 5 to 42 degrees API, fairly flexible application method, efficient power usage. Disadvantage is sensitive to overpressure, sensitive to pump off, restricted flow rates up to 5,000 barrels per day. There are some anyway, there are some exceptions, but commonly is 5,000 barrels per day, restricted setting depths. That's an issue. Limited operating temperature, not compatible with some chemicals. There are some nowadays there are PC pumps available in the industry actually, which has got a liner, metallic liners, and they can live with high temperature. Gas lift is the next application. Uses additional high pressure gas to supplement formation gas. Produces fluids are lifted by reducing fluid density, and by reducing fluid density, flowing bottom pressure becomes more than the static head pressure and flows to the surface. Gas lift as an artificial method decreases the fluid average density, thus the hydrostatic load and formation is reduced. By injecting relatively high pressure gas from the surface to predetermined depth in the wellbore, the average specific gravity of the fluid decreases, which causes a drop in the wellbore and pressure reductions. Yeah. According to Darcy's law, turn on increased fluid production. So this is another gas lift system configuration. You can see it is coming from this is tubing, and the mandrel installed at different depths, and gas injected from the surface through the tubing, and the fluid is produced through the annulus to the tank, where the gas is separated and then stored into to the tank. So gas is injected from the annulus all the way. Fluid is lifted. I'm mixing up. What happens is the gas is injected in the annulus all the way, and the fluid is lifted in the tubing and goes all the way to gas separator. It separates the gas, and the fluid goes into the tank. Yeah. So these are gas lift system configurations. The advantage is fairly low operation cost, flexibility, can change rates by adjusting injection rates, and adjusting injection rates or pressure. Also easy to change gas lift valves without pulling the tubing. High volume lift methods, 35,000 barrels per day typical. Very good for sand deviated valves. Disadvantage, must have a source of gas. If gas is closer, it will require treatment. Possible high installation cost. Actually, initial cost is very high, but in the longer run, the cost is much lesser. But I have run a comparison actually when in my working career in early stages. I found actually, in nutshell, you have gas lift is more expensive than another lift. So if you compare gas lift and ESPs, gas lift becomes comparable after 8 years of running its life. This is a very generic concept, cannot really specify. Yeah. In a nutshell, actually, we can compare the gas lift if it's available. It's easily used. If gas is available, it's less costly. People can be trained on it very efficiently, and it's most commonly used. But now, industrial trend is switching over from gas lift to basically to ESPs or even with the PCPs. Yeah, because of the cost of the gas itself and the maintenance cost, it's no more feasible or economically feasible. This is the common understanding. Yeah. Hydraulic lift. This kind of system is not installed commonly around the world, and also in Oman. I have worked actually installed in some water wells in some areas in Oman, but this is very economic and feasible system in some of the areas, but it's not very efficient, because you are producing fluid, well fluid with injection fluid, and you have to separate it. Actually, somewhere or other, you have to pay separation costs in addition to the existing setup. So hydraulic system transfer energy downhole by pressurizing special power fluid, usually water or light refined oil, pumped through a well tubing and analyzed to a subsurface pump, which transfers the potential energy to produce fluids. Common pumps consist of jets, venturi, and orifice nozzle, reciprocating no pistons, are less widely used in turbines. Yeah. So advantages of jet pumping: no moving parts, can tolerate solids and deviated well bore, no rig required to replace pump due to wear and productivity changes, simple completion significantly, chemicals can be injected with power fluid, no rig required to change nozzles and zones and tandem well, low capital cost per unit production. Disadvantages of pumps are low system mechanical efficiencies, high fuel energy running cost, high surface maintenance cost, industry not familiar with the system due to past monopolies, supply or poor marketing product knowledge. Hydraulic piston pumps are offered as an alternative to jet pumps, higher efficiencies up to 95%, reciprocating system to lift production to surface, hydraulically retrievable, similar flexibility in design and application. Ideal hydraulic pumping system consists of this setup. You can see that SPS hydraulic pumping system, for surface system, for the downhole equipment, a complete system. This is your surface system, and this is separation system. A multi-well installation drive by, it can be done also by hydraulic pumping system. You can see that this is connected to header and it can pump to multi-wells. And this is also portable testing units, available in the market. Principle of operation is jet pumps can be used as an alternative to piston pumps. They can fit interchangeably into bottom assemblies. Shorter bottom assembly can be used. Jet pump assemblies can be shorter and higher flow, referred to as a feed, far back as 1852. First patents for oil well surgeon user was in 1930. Jet pump overview. Pumping action achieved with energy transfer. High pressure fluid passed through the nozzle. Well fluid intermixed at the exit. Mixture passes through the expanding area diffuser. Pressure of the mixture must be sufficient to reach the surface. So this is the concept of velocity head and pressure head together. You can see that it is, it's reciprocating system. When its pressure head increases, the velocity reduces. Yeah. These are nozzle and throat selection. You can see that picture. No moving parts. Flow passages can use exotic materials or heavy oils, paraffin, gas, and corrosive area. Reservoir needs a relatively stronger drive. 100 psi per 1000 feet as the guideline. Yeah. And offer ruggedness and reliability and volumes. Guidelines is a PF pressure 2000 to 4000 psi, maximum well depth is 3000 to 12000 psi, production capacity is 15 to 10,000, and total length of jet pump section is 1.5 feet, very small. Performance on nozzle throat area is ranges from 20 to 60%. It's a different N to T combination provide range of selection defines effectiveness of power fluid injection, power fluid to lift, and input horsepower. Higher fill lift, more pressure, more efficiency, up to 5,000 psi. This is the ratio, which is FAD by AN. FAD is a dimensionless area ratio, AN is area of nozzle, and AT is throat area. So high head, low flow pumps when nozzle is 60% of the area of the throat, less flow area around the nozzle, low production rate, and deep wells. And low head, high flow pumps is when nozzle is 20%, here is 60%, is 20%. More flow, high production rate, higher injection pressure. And it is, velocities are typically 200 to 300 feet per second in throat area. Equipment selection, balancing the following: jet pump components in nozzle too small, will only circulate power fluid. Power fluid pressure could be too high for required lift. If the throat area is too small, cavitation happens. And power fluid supplied is goal is minimum high pressure and maximum production. So friction consideration is the goal is keep losses to minimum for applications. Yeah. So these are the concept of application ranges. I don't want to go in detail, but you can see that 3.5 inches can go up to 15,000 feet and 10,000 barrels per day. These are the piston type pumps, and these are the jet pumps. You can see the comparison, but mostly advantage of piston pumps are over the others in comparison to pressure, operation, and lifting the fluid level, and application in depth. So typical hydraulic pumping system, you can see that it's a big surface setup. Open flow power fluid system is power fluid is produced, casing free installation, simple design, most economical design, ideal for chemical treatment, allows circulation in the fluids. Yeah. So in closed power fluid systems is a minimized power fluid treatment, excellent in abrasive corrosive fluids, excellent in flow, and piston pumps and some reciprocating system actions are rod pumps, ideal for low flow rates, low intake pressure, high efficiency, and maximum flow rate. These are our standard wellhead and downhole systems. You can see that. Surface installation and downhole system is a bit of complicated, but Now coming to ESPs, finally, ESPs are the most commonly used. They sold in Oman and also around the world. 85% production is rendered by electric submersible pumps. So electric submersible pump system are multiple pump stages mounted in series within a housing, mated closely to submersible electrical motor at end of the tubing and connected to surface controls, electric power by an armor protected cable. It transfers electrical energy from surface to downhole surface. This is the combination of electrical system. You can see there, this is a motor, protector, pump, gas separator, and the pump itself. All right, so we'll go one by one. Electrical submersible pump system is ESP is the electrical submersible pumping system transfers electrical energy from the surface to downhole motor that converts into mechanical power. This rotational movement turns the pump's impellers and lifts the well fluid to surface. The ESP was introduced as a means of artificial lift by REDA in late 1920s. These are wide variety of pump sizes, capacities, and motor horsepower, voltages for different applications. This was initially in 1920 was used to pump off the water from the mines, but eventually actually took the place in the oil industry. Now it's the most widely and commonly accepted means of lifting. ESP, I'll start from the bottom, I start from the bottom here, you can see this, from here, So motor, then I'm talking about protector, gas separator, and the pump. Yeah. So ESP motor is a 3-phase squirrel cage 2-pole induction design. It's the heart of the system since it provides the torque required by the downhole pump. Motor components are the stator and the rotor. The stator is composed of the housing material for a desired diameter, the stator core and the stator winding, copper wire. The housing material forms the cover for the motor and is threaded with both ends for head and base components. Stator lamination, you can see there are different series, 540 and 562 series motors, depending on the well IDs and wellbore IDs. You can install relevant pumps and the sizes. 540 is commonly used. 562 is, you can see the comparison in the size. Yeah. The motor components is rotor is made up of a rotor lamination that is smaller in diameter from the stator lamination, and these create the iron core. Inside in each slot are copper bars. You can see these copper bars and iron core together, and sporting copper end rings here. These are the rotor lamination with the copper bars. You can see that's copper bars and lamination of 540 series. These motors are available in a number of different sizes, voltages and horsepower ranges, and depending on the application. This is, you can see the catalog. It can tell you the motor voltages, sizes, and the amperages, and different series. It has to be selected from them. There are software available actually which can select for you the motor and the pump together, like sub pump and flow sys, and this. Next system is protector, which is installed on top of the motor. It separates the well fluid from the motor, and it protects and connects the motor to the pump. The protector is located directly above the motor. So ESP functions of the protector is couples the torque developed in the motor to pump via the protector, prevents the entry of fluid into the motor, provides pressure equalization, houses the bearing to carry the thrust developed by the pumps, provides a reservoir of the thermal expansion of the motor also, because this is shaft here, it takes the load also, and this is when because the temperature fluid, the motor is filled with the fluid expands, then it accommodates the expansion of the fluid. ESP gas separator is, in some application there may be gas produced along with the oil and water. You can install it actually, and you can install it and on the top of the motor to install, to separate the gas, and to supply the fluid free of gas to the pump, because pump is not meant to operate at gas. Only it works on fluid. So in some application, there may be some gas produced along with the oil or water liquids. And if gas is present, then gas separates can be installed and becomes the pump's intake. It assists in eliminating some of the gas that might be produced through the pump. ESP pump is the next component which is installed on the top, and this is the major component actually, component of the system. These are multi-stage centrifugal pumps. They are installed on top of each other. It consists of numerous impellers and diffusers. Application depends to provide the lift pressure required. The pump has a discharge head and at the tubing screws. This is a discharge head here, and these screws into the tubing. So also screws in the tubing also here, and this is installed right on the top of the protector. ESP pump is a centrifugal pump is a machine that moves the fluid by spinning it with the rotating propeller inside a stationary diffuser that has an internal inlet and a tangential outlet. This is maximum head capacity for the different pumps. You can see that with the reducing the head capacity, flow rate is increased. So if you want to pump 20,000 feet depth, and your head capacity is, flow production is reduced to almost about $1,000, $2,000. But if you compromise on landing depth and the head capacities, you can go up to $30,000. Yeah. So depending on the different casings and casing sizes and tubing sizes. This is a pump performance curves. ESP operates in 3500 RPM, a 60 cycle power supply, a 2900 RPM, and 50 cycle power supply. These are different curves here. You can see this is an operating range of the pump, and this one is your pump efficiency curve, pump performance curves, and this is your head curve, and this is your motor horsepower rating. And you have to pick it up actually, and manually or even with the kind of software installed, you can pick up the right pump for the right size. Yeah. The ESP power cable is the next one, and this motor relay extension. This connects the power supply from the surface to the motor. This is your motor lead extension. It goes into the motor, and the power cable comes along with the tubing, is coupled to the tubing all the way to the surface. ESP power cable consists of 3 copper conductor wires extending from the top of the motor to the flat cable lead to the wellhead. The size of the cable selected is based on amperage and the voltage drop. Bottom hole temperature and fluid operates is critical for the selection of the cable. The electrical cable has been refined over the years to be used specifically for oil well locations. Components is the conductor, insulation material, barrier jacket, jacket material itself, and then the exterior, which is called armor. Yeah. This is all devices to protect it from the well fluid. So these are transformers, switchboard, junction box, and go to the wellhead. So ESP surface equipment is the wellhead is a device that is installed in the surface on the wellbore casing. Purpose is to support the tubing, string, cable, and the ESP connection, and high pressure conditions often present within the casing. Special wellheads are required for each and every combination. These are the wellheads required to penetrate the cable and the tubing together. Electrical transformers are required to deliver the correct voltage of the motor. A step down transformer, a step up transformer. Transformers can be either single or phase or 3-phase, as I showed you. And this is an overall system. You can see that this is your ESP assembly, actually motor, the perforations, wellbore, motor, protector, pump intake, pump, joint of tubing, check valve if it is required, drain valve if it is casing is installed here, tubing, go to the wellhead installed, and the production string to the wellhead. And this is electric power cable, junction box, motor controller, transformers, and main power supply. The ESP junction box provides a connection point for the surface cable from the motor control panel to VST for the power cable. But what happened, it's very strange. When you are installing the cable, cable is so, mostly new cable. With the passage of time, it deteriorates the integrity. The cable is prone to well fluid and temperature and pressures, and also all kind of solvents. So we have to avoid the gas entry into the cable. Normally, when it enters with the passage of time, it has to not flow to the system, so it is vented in the junction box. Junction box provides a connection point for the service cable from the motor control panel to VST, the power cable, and the wellbore. Allows for any gas to vent from any migrated through the power cable. Provides easy surface access to the point of electrically checking the downhole equipment. ESP switchboard is the next component. Yeah, it provides the surface equipment, it provides the power supply and the controls. Yeah, you can see this here. The switchboard is used to energize the motor. It contains the motor controller, which monitors the running parameters and provides protection to the system. The controller also provides the capability to monitor the production system with the use of recording instruments. You can see that these are recording instruments, cable, motor controller, and these are power supplies and fuses. Yeah. VSD is now, as I mentioned earlier, actually, because for each and every company, combination and installation, there are various sets of ESPs and motors with the relevant speed and voltages and amperages. Now, in case it is a fixed speed motors and fixed speed production. You can see if you go back to the pump curve, you can find actually with the passage of time and increase the velocity or speed, it can increase the production also. But what to do if it's a fixed system? So in this kind of system, you can install the VSD, variable speed drive. In the same system, you can change the motor amperage in the motor, and also it can control the production also from various systems. So in case of areas where your well data is not very well known, and mostly in new areas where your well data is not very firm, so you can install the VSA system just to operate at different ages, and you can still keep on producing. But mostly the VSD are fixed speed systems installed in the areas which are productive and fairly developed areas, and the system as a whole. Yeah. Advantages actually can achieve high production rates. When VSD operated, can offer flexibility to accommodate changing conditions, the PI, water guard, flowing water pressure, reservoir pressure, etc. Can be used at low bottom hole pressure. Can operate reliably in deviated and offshore wells. Can sometimes operate below perforations. Can operate under conditions such as higher bottom hole temperature, and which is used for alternate materials. Can be utilized to test the wells by using a portable VSD, particularly in new areas for testing systems. So ESP's disadvantages: a pulling unit is required to retrieve the failed ESP regardless of the failed component. Expensive intervention costs. High temperature effect cable and motor installation. High dogleg severities are a problem. Available electrical power for required horsepower. Use of switchboards, constant speed, limits the flexibility and production. Higher gas content can limit the system capabilities. High solids may cause rapid wear and premature failures. ESP summary in a nutshell: electric submersible pump system uses multiple pump stages mounted on sides within housing, mated closely to submersible electrical motor and the end tubing, and connected to surface controls and electric power by armor. Wide performance range, can operate in deviated wells, most efficient and common commercial lift methods. Tubing must be pulled to change the repair. Depth and gas oil ratio restricts capacity, and large volume of gas can lock the system. That ends my presentation. Now I'm inviting questions. If there's any question, please you can send it to me, and I can answer. We still have time. Any questions, please? I can see, from my chat board. Any question, please? on artificial lifting in Oman and worldwide. Yeah, there is a question by Omar Al-Abri that can we use PCBs metal to metal type for steam production? Yeah, actually this is mostly used in PCBs are used for steam injection and steam production in different parts of the world. Nowadays, actually, when you go back to PCB system, let me pull it out and show it to you. In PCB system, you can see this one is, our this is a rotor and this is a stator. So stator has got a rubber lining actually, and this is prone to temperature, and it is meant for a certain temperature ranges. Commonly, it can be installed only by up till 80 to 100 degrees centigrade. But some areas, where your elbow conditions are very high, up to 220 degrees, this lining is changed to metallic one. And it's a soft metal actually, which can accommodate the cavity and which can accommodate the rotor also, without changing the profile. But it's a bit costlier system. The metals are very bit expensive, and also typically different concept for using. Any other question, please? Still have 10 minutes. Yeah. Hello, everybody. Any question, please, before we end the session? Still have left about 10 minutes to go. I can see some participants from Indonesia. Yunus Mo. Mo Yunus, sorry. Nice to hear from you, Yunus. Yeah, I see. This artificial lift is actually is uh, is uh, getting up and gearing up actually in different part of the world now, and I understand actually some part of the world and also in Oman, the people are replacing gas lift with the ESPs basically because the initial cost of gas lift system is pretty expensive, but even though in the long run it's economic and feasible, but gas availability and because of the cost of the gas and supply issues and line leakages and duration of the system, it is they're losing track and they're replacing with the ESP system. Now ESP system has got an advantage that it can be installed anywhere in the desert, maybe without any strategic facilities, no electricity, no, physical or civil, restrictions or even facilities available. You can install the ESPs. It can run on a generator and diesel generator also if power supply is not available. It can go right from up till 20 barrels to 30,000 barrels depending on the application and the VSD. Slim ESPs are also available nowadays. High GOR ESP is available. Highly corrosive areas ESPs are available. PCP is taking pace with the different areas of the world now. And since when the metallic lined ESPs, PCBs are coming in the market, they are used mostly for steam application. They are used mostly for corrosive environments, and they are used for high temperature environments. So PCP is also gaining, popularity with the best of time. So mostly, I should say the ESP and PCPs are taking care. Rod pumps are the oldest system now installed in the world now, but it's meant for low production and low depth areas. Yeah, but for complicated and high GOR and corrosive areas, mostly ESPs and PCPs are taking over. And now ESPs almost has beaten in population to all other systems. Yeah, but you cannot say that it's all applicable to the application, individual application, depending on the wellbore condition, corrosion environments, temperature, deviation, surface facilities, all together, depending on. And since I've shown you the criteria, you have to judge yourself, which is more feasible part for you, like this, how to select different areas like this. You have to have make a selection table to which fits most to your area. And at the end of the day, economics actually prevail. Yeah, cannot say really which one is the more feasible area. Yeah, this all depends. Yeah. So the wellbore conditions, surface facilities, and also the economics. These are the three deciding factors in selecting any artificial method. Yeah. So cannot simply close your eyes, but it can. The most feasible things is, you can really optimize the system as long as you wish. So optimization is always a key to your success. Even in your existing system, you can reduce the work hours. You can reduce, if you have got a proper knowledge of the system. There are softwares available in the market which can design the ESPs and PCPs or any kind of lifting system. And then you should have a proper training, to train your people to run the system. But all depends actually once you installed it. You have to have a proper knowledge to keep operating and keep the system within the envelope. Whatever pumping system you should install, it should operate within the envelope. It should not be under thrust or over thrust, and it should not, pumping, dry it should run within the range. That's the key to your success. As I showed you, here, it should operate actually within the operating limit. Yeah, this one, this operating limit. As long this is down thrust, this application, this is up thrust. But you should see that actually the impeller should not touch the diffuser. If you are going to do this, you are going to ruin the pump. So it's going to cost you the workover, cost the pump itself. And as long as I have an experience with the areas which have installed ESP running for 10 years more than. But commonly, we could obtain run life up to 3.5 years, generally, And wherever the areas, which we really new areas we were establishing and we are trying to establish a trend, it went only for 6 months. Then we picked up the problem, we studied the system, and we found it can be optimized. So in the same areas, the same well which is running 6 months now, is running for 3.5 years. And sometimes, exceptional cases maybe, yeah, but it ran more than 10 years, yeah. So there are ways to handle the system actually, because you have to take care of the system and its operation, yeah. Any question, please? I'm ready to take any question. Yeah, but most commonly the question is asked actually which lift system is most appropriate to your system. So I told you have to go and do your homework to pick up the criteria. As I showed you in early stage, you have to different criteria and which system fits your application. At the end of the day, economics works. Yeah, and also nowadays actually because there are most of the vendors available in the market and then come up and run the system on a contractual basis. If you can enter into a kind of a rental agreement or operation agreement, the contractor can run the system for you. You don't have to worry about the new equipment buying, and the lease agreements are in place nowadays. Contractor brings the equipment, they design the system, they run and they operate it actually, and you simply pay them a rental cost, maybe a daily cost or monthly rental for the equipment. So they take care of the operation, the run life. All you have to do is actually you have to bear with the rig cost if you come up. But since it's in contractors in on areas of interest, they try to extend the run life because they want to live longer with the same equipment and reduce the operating cost. So this is true with the PCP. This is true with the ESP. The lease agreements are in place now, and I knew that actually I have established one of the most first agreement actually in Kuwait. We did lease agreement now. This kind of lease agreements are in place now. In Oman also for the PCPs and for ESPs altogether. Yeah. So, but the concept is actually as long as your people are there, they should be trained. They should be. This is not a hilltop task actually. All we have to do is actually in the human nature. You can live with the difficulty probably if you get used to. Yeah. So if you train your people properly, if you have a good knowledge of your well and good knowledge of the system, you can extend the run life and you can reduce the cost drastically. Yeah. So there is no magic. It's all efforts and struggles. Yeah. So we'll be ending the session now. It's 12:30 now, and all the best and thanks for sharing with me. Hope to see you again. Thank you for sharing with me. Bye. Awesome. Yeah, Habibi, now session is over now. So what to do? So switch off? Alhamdulillah.